You are welcome to the GMAT 41's mathematics class. In our class today, I'll be teaching you lowest common multiples, part 1. At the end of the class, you would have come to learn about lowest common multiple, what it is, and how we can solve and obtain the lowest common multiples of 2 or more numbers and the highest common multiples of 2 or more numbers. First, what is L.Cm, lowest common multiple of 2 or more numbers? So I have the explanation here on the board. The lowest common multiple of 2 or more numbers is the smallest number, the lowest number that the 2 or more numbers can divide without leaving a remainder. For example, if I give you 2 and 3, and I ask you what's the LCM of 2 and 3, all you need to do is to find out the lowest number that 2 can divide, and 3 can also divide that number without any remainder. That number will become the LCM, the lowest common multiple of 2 and 3. Apart from saying that lowest common multiple is the smallest number that 2 or more numbers can divide without remainder, we can also look at lowest common multiple in another way. Alright, here on the board we have this. The first lowest number which occurs as a multiple of 2 or more numbers is said to be the lowest common multiple of these 2 or more numbers. Once again, the first lowest number that occurs as a multiple of 2 or more numbers is also known as the LCM of these 2 or more numbers. I have this example quickly on the board that I'm going to use in explaining to you better the idea of lowest common multiple. On the board here, we have this example. Okay, this multiplication table of 2 times and this one of 3 times, just a little extract. You know, the GMAT 41 has always told you about how important your multiplication is. I want to believe that by now you have worked on your multiplication table very well and memorized them as much as you can. In our previous class, I taught you about rules of divisibility. The knowledge of multiplication still helps us to understand these rules better. You know, like I told you in past classes, without multiplication, I wonder how you can survive division. It really would not be possible. So please, make sure you practice your multiplication table regularly. Alright, now we have this example here. We're trying to find out the LCM of 2 and 3. So as to help us understand the real meaning of LCM, lowest common multiple of 2 or more numbers. In 2 times table, if you do 2 times 1, you get 2. 2 times 2, you get 4. 2 times 3 will give you 6. 2 times 4 will give you 8. 2 times 5 will give you 10. 2 times 6 will give you 12. I decided to stop at 2 times 6. You know that this is simply the first multiple of 2 will give you 2. Then this is the second multiple of 2. The third multiple of 2 is 6. The fourth multiple of 2 is 8. The fifth multiple of 2 is 10. The sixth multiple of 2 is 12. Alright, let us visit 3 times table and see. The first multiple of 3, which is 3 times 1, will give us what? 3. The second multiple of 3, which is 3 times 2, will give us 6. Look at the third multiple of 3, which is 3 times 3, get 9. 9 is the third multiple. What about the fourth multiple of 3? To give us 12. 3 times 4 is 12. Now I want you to look at this line I drew here with 2 arrowheads. 2 times 3, that is the third multiple of 2, give us what? 6. 3 times 2, that is the second multiple of 3, also give us what? 6. If you look at the numbers above in 2 times table, we have 2, we have 4 here. In 3 times table, the number above 6 here is 3. You will notice that when you move on to 2 times table and you start working on 2 times table down, and you also work on 3 times table down, the first number that you would see as a multiple of 2, and also as a multiple of 3, that first number is 6. When you're reading down here, you see you have 6 here, and you come to 3 times table, you also have that 6. So 6 is the first lowest number that is a multiple of 2 and also a multiple of 3. We can say that 6 is the first lowest number, which if you go to 2 times table, you will see that 6 there. If you go to 3 times table, you'll also see that 6. Now if you move down, you notice something, another number that is common that you can see in 2 times table and also in 3 times table, which is also a multiple of 2 and 3, is 12. That's the next one you would see, which is in 2 and also in what? 3. 12 is another common number. But let me ask you, 6 is a common number, a common multiple in 2 and 3. 12 is also a common multiple in 2 and 3. But which one of the two, 6 and 12, is lowest? 6 is lower than 12. Therefore, 6 becomes the lowest common multiple of 2 and 3. If you continue still, you will still meet another common multiple. But that common multiple will be greater, will be bigger than 6. Remember, we say that lowest common multiple is that smallest number, which 2 or more numbers can divide without remainder. So here, 6 is the lowest common multiple of 2 and 3. It means that 2 can divide 6 without remainder, 3 can also divide 6 without remainder. Let me ask you this question. What if I ask you the LCM of 2, 3, and 4? It means you have to also think about 4 times table. If you go to 4 times table and do 4 times 1, you get 4. 4 times 2, you get 8. 4 times 3 will give you 12. Now when you compare 2 times, 3 times, and 4 times, you will notice that the first smallest number that is common to 2, common to 3, and common to 4 will be 12 in that case. 6 will no longer be the common multiple because in 4 times table, 6 is not there. You cannot do 4 times any number to get 6. So if I am to include 4 here, say, okay, the LCM of 2, 3, and 4, the lowest common multiple there will now give us 12. So that's the whole idea about LCM. Now, does it mean that if a question is given to you, maybe I ask you to find the LCM of 20 and 35, you will now start doing 20 times table and 35 times table. Is that what you would do to get your LCM? The answer is no. And that is what I'm going to teach you, how you can easily get the LCM of 2 or more numbers, how we actually solve them. So let us see that next. How do we get the LCM of 2 or more numbers? I'll be explaining that to you now, and then we'll solve a question to demonstrate the explanation. On the board here, we have the procedure written. To find the LCM, that's lowest common multiple of 2 or more numbers, all you need to do is to divide these 2 or more numbers using a smallest number that can divide any one of these 2 or more numbers. Now, when you use a smallest number that can divide any one of these numbers, suppose that smallest number cannot divide any one of these numbers, all you have to do is to bring down the number that cannot be divided. Continue bringing it down until you get a number that can divide it. Once you've done that, if each of the columns of the number whose LCM you are looking for, if each of the columns gets to 1, then you can stop. It means you've concluded your division. How do you now get your LCM? Finally, multiply all the numbers used in dividing to get the LCM. So that is what this short note is explaining. Is that okay? You can read through it. I have a question here I'm going to use in demonstrating what this note is talking about. We are to find the LCM of 2 and 3. Remember, we already stated that the LCM of 2 and 3 is 6 when I used 2 times table and 3 times table to check it. But I told you that is not the best way of finding the LCM of 2 or more numbers. So let us see how we solve this question. Find the LCM of 2 and 3. Solution. What I will do is to create 2 columns because there are 2 numbers whose LCM I am to get. 2 and then 3. These are the 2 columns, one for 2, the other for 3. Then I will start dividing this. I will pick a smallest number that can divide any of these numbers. So we have these numbers here. Okay, so which number will I pick that can divide either 2 or 3? But remember, the number you are to pick is the smallest number. Now, this is what you should know. We usually start by checking if 2 can divide the numbers. Whose LCM we are looking for. We always start by testing using 2. So I will come here and ask myself, can 2 divide any one of these numbers? And the answer is yes. 2 can divide 2. Remember the rules of divisibility. Or you think of multiplication table of 2, you know that 2 times 1 will give you 2. So if you do 2 divided by 2, it will give you 1. So I will use 2 to divide. I'm using blue marker to show the numbers I'm using to divide. If these 2 divide 2, it will give us 1. Can 2 divide this 3? 2 cannot divide 3. Again, the rules of divisibility, or you check from 2 times table. Can you multiply 2 by any number to get 3? No. Now there is something we have here. Any of these numbers which cannot be divided by the smallest number used in dividing, bring it down continuously until it can be divided. So here, these 2 cannot divide this 3. So what will I do? I will bring down the 3. Bring it down. Okay, now you notice that this column, look at this column of 2 has reached 1. So this one has finished its division. Are you getting? You move on again. This one has not gotten to 1. So you have to divide this. Can I use 2 to divide again? Can 2 divide this number here? No. Remember I told you this one has reached 1 already, so you are done with this column. 2 cannot divide 3, so you forget about 2 now. You move on to the next higher number, which is 3. Check if 3 can divide this 3, and yes, 3 can divide 3. So it's 3 I'm going to use now. This is already 1, so you can bring it down if you want. Okay, because this has finished its division. So you can bring down the 1. Or you say 3 into 1. 3 cannot divide 1, so you bring it down. Okay, come to this. 3 can divide 3, and it will give you what? 1. So you see, you have reached 1, 1 in each column. We have a statement here that said, stop dividing when each column of these numbers gives 1. You see that each of the columns has given us what? 1. So we can now stop and get our LCM. I'll conclude therefore, LCM of 2 and 3 is equal to, finally, multiply all the numbers used in dividing to get the LCM. So these are the numbers I used in dividing, 2 and 3. So I'll multiply them. 2 times 3. And if you do 2 times 2, what will be your answer? 6. 6. So this is the LCM of 2 and 3, just like we already explained previously. We are going to see more questions on how to get LCM of numbers. In this video, let us find the LCM of 8 and 12. We are going to be fast in solving this problem. Remember, the secret is very simple. Once you know how to do your division, then you don't have any problem with LCM. But to be able to handle division fast, you need the knowledge of what? Multiplication. Let us see how we solve this problem. Find the LCM of 8 and 12. So these are 2 numbers. It means I will create 2 columns. One for 8, the other for 12. This is what we mean by columns, alright? 2 straight lines coming down here gives us column. Alright, looking at this, what's the smallest number that can divide any of these 2 numbers here? We have 8 and 12. The smallest number that can go, 2, can divide. So let us use 2 to divide. If 2 cannot divide 8 and 2 cannot divide 12, you won't use 2. Take note. If 2 cannot divide any one of these, then you cannot use 2. It means you now have to check if 3 can divide it. But good enough, 2 can divide here, so we go. 2 can divide 8, you get 4. 2 can divide 12, you get 6. Again, look at these 2 numbers. Can 2 still divide? Yes, 2 can still divide. 2 can divide 4, you get 2. 2 can divide 6, you get 3. Okay, so we come to this now. We have 2 and 3. Can 2 divide again? Yes. 2 can divide this number 2 here. If 2 divides 2, you are going to get 1. Alright, then this 3. Can 2 divide 3? No. 2 cannot divide 3. Therefore, I'm going to bring down these 3. Okay, now, can 2 still go here? No, 2 can no longer go. Look at this. This is 1 already, so this column has reached its end. You are now left with this. 2 cannot divide 3. So forget about 2 now and check for the next bigger number, which is 3. I will check, can 3 divide any number here? Yes, 3 can divide 3, so I will use 3 to go. Remember that this column of 8 has reached 1, so we'll still just bring down 1 if we want. If I don't want, I can just leave it 1 like that, okay? Move on to this, 3. 3 can divide 3 and we'll get what? 1. So you see, you've gotten 1 in each column. So you stop and conclude. Therefore, LCM, the LCM of 8 and 12 is equal to, now what we have to do is to multiply. Let me put equal to here. We're going to multiply the numbers I used in dividing. And the numbers I used in dividing are 2 times 2 times 2 times 3. These are the numbers that I used in dividing. So let us find out. 2 times 2 will give us what? 4. Alright, then 2 times 3 will give us 6. 4 times 6 is 24. Or you can say 2 times 2 is 8. 8 times 2, or 2 times 2 is 4 rather. 4 times 2 is 8. 8 times 3 is 24. Okay? This is equal to 24. Therefore, the LCM of 8 and 12 is 24. And that is our answer. We will solve yet another question that will not just come straightforward like this. Maybe we will make the statement a bit tough. That's the next question we are going to look at. Let us look at this question here that talks about the smallest number that is divisible by 100, 120, and 150. What is this question about? So it's like we have one number, and we are told that that number is the smallest number that 100 can divide, 120 can divide, and 150 can divide. Remember the definition or the meaning of LCM. The smallest number, the lowest number that 2 or more numbers can divide without remainder. So if someone is asking you, find the smallest number that is divisible, that is to say that can be divided by 100, 120, and 150. It simply means that they are asking you to find what? The LCM of 100, 120, and 150. Do you understand that? Okay, so let us see how we solve this question. I'm going to solve it on the other side of the board. And we are going to be fast in that. Solution. Okay, solution. I will draw how many columns here? 3 columns, because we are looking for the LCM of 100, 120, and 150. So we have 100, 120, 150. Then we would now start dividing using the smallest number. We check 2 first. Can 2 divide these numbers there? Yes. Remember the rule of divisibility. When any number ends with 0, that's the last digit of any number is 0, 2 can divide it. So I will start with 2. Remember, you will always start with the smallest number that can divide. So 2 can go. I'm going to use blue marker. If 2 divide 100, what would we get? We'll get 50. Okay? Can even take it in a short division way. 2 can divide this 10 to give you 5. You record 5. Then 2 to 0 here will give you 0 because 2 cannot divide 0. Bring down the 0. Okay, so this is going to give us 50. 2 can divide 120. If 2 divides 12, it will give you 6. Then bring down your 0 because 2 cannot divide out. It says 0 divided by 2 give you 0. You bring down the 0. Come to 150. 2 can go into 15. How many times? 7 times. But there will be a remainder. If you go to 2 times table, 2 times 7 will give you 14. And you are dividing 15, so the remainder will be 1. What do you do with the 1? Remember, you have another digit here. So you attach the 1 somewhere here. You get 10. We've done something like that in previous classes, in past classes before. So if you attach the 1, which is the remainder here, 2 can divide 10 and you get 5. Good. So we go again. From what I'm seeing, 2 can still divide because this digit ends in 0, this one ends in 0, so 2 can still divide. If 2 divides 50, we'll get 25. If 2 divides 60, we'll get 30. Can still do short division like I said. If 2 divides 5, it will be 2 times, look at it, remainder 1. Attach the 1 to this 0, you get 10. 2 divides 10 gives you 5. This is 60. 2 can divide 6, here you get 3. Then 2 divides 0, it's 0. 0 divided by 2 will give you 0. Now we have 75 here. Can 2 divide 75? Oh no, 2 cannot. Rules of divisibility. Divided by 2. 2 can only divide a number that the last digit is even or 0. Here the last digit is 5. 5 is not an even number. So 2 cannot divide it. You bring it down. Remember, because 2 cannot divide, you bring it down. Go again. Can 2 divide any number here? Yes. 2 can divide this 30 because it ends with the last digit there is 0. So 2 can divide. This is 25. 2 cannot divide it because the last digit is not even number and it is not 0. So you bring down this 25. If 2 goes into this 30, that will give you 15. How did I know? 2 can go into 3. How many times? 1 time, but there will be remainder. Because if you go to 2 times table, you can't multiply 2 by any number to get 3. But 2 times 1 will give you 2. And you are dividing 3. So the remainder will be what? 1. Attach the 1 to this 0, you get 10. 2 can divide 10, and that will give you what? 5. So you have 15. 30 divided by 2, or 2 divides 30, will give you 15. Here you bring down your 75 because 2 cannot. Okay, now at this point now, can 2 divide 25? Can it divide 15? Can it divide 75? No, 2 cannot divide any one of them again. So you now move on to the next bigger number. Check for 3. Can 3 divide any one of this number? Let us go to the rule of divisibility by 3. How do we know that a number can be divided by 3? If you add the digits in that number, and what you get can be divided by 3, it means that 3 can divide that number. So let us check here. This is 2 plus 5, you get 7. 3 cannot divide 7. Because in 3 times table, you cannot multiply 3 by any number to get 7. Okay, this is 15. The digits are 1 and 5. Add them up. 1 plus 5 will give you 6. 3 can divide 6. So 3 can divide 15. It means that I will use 3 because at least there is a number there that 3 can divide. 25, 3 cannot divide it, so you bring it down. 15, 3 can divide it, you get 5. 75, can 3 divide? Let's check. The digits there are 7 and 5. If you add 7 plus 5, you get 12. 3 can divide 12. In 3 times 2, 3 times 4 will give you 12. It means that 3 can also divide 75. So let's find out what it will give to us. If 3 goes into 7, in 3 times 3, you see it to be 2 times. But there will be remainder. That 2 times, 3 times 2 will give you 6. And you are dividing 7, so the remainder will be 1. Attach the 1 to this 5 here, you get 15. 3 can go into 15, 5 times exactly. It means that 75 divided by 3 will give you 25. Okay, let us check. Can 3 still divide here? No. If you check, 3 cannot divide any of this number again. So you move on to the next bigger number, 4. Can 4 divide any of this number? No. If you check from 4 times table, you cannot multiply 4 by any number to get these numbers here. So we move on to the next higher number, which is 5. Can 5 divide any of this number here? Yes. Remember rule of divisibility by 5. Once the last digit of a number is 5 or 0, then 5 can divide it. And of course, you can see this one ends in 5, this is 5, this one ends in 5, so 5 can divide. I will now use 5 to divide. 5 goes into 25. From 5 times table, it will go 5 times exactly. 5 divide 5 will give us 1. This column has reached 1, so you have finished this column. 25 divided by 5, or 5 divides 25, will give you 5. We will still go again because there are 2 columns that have not reached 1. This and this. Can 5 divide them? Yes, 5 can divide 5, so I'll use 5. If 5 divides this 5, it will give me 1. Bring down your 1 here. This one will give me 1 also. You've reached 1, 1, 1 in each of the columns, so you stop your division and then write out your answer. Therefore, LCM of 100, 120, 150 is equal to, if you multiply the numbers you use in dividing, 2 times 2 times 2 times 3 times 5 times 5. Do the multiplication and you would get this. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Then look at this number. This is 5 times 5, which is 25. You see, when I have 24 here, if I'm using 24 to multiply 5, it may stress me a little. So the best thing you can do when you get this to be 24, that is from here to this 3 to be 24, you can quickly do a rough work. 24 times 5 times 5 is 25. So you put 25 and multiply. That will give you 600 actually. But let's do it and see from multiplication. I've already told you, and the GMAS 41 will continue to sing it. By the time we come, we'll stop talking about how important multiplication is. So now you have the opportunity, make sure you learn your multiplication very well. So let us go. 5 times 4 will give us 20. So you write 0 and carry what? 2. Remember that you carried 2. 5 times this 2 will give us 10. Plus the 2 you carried, 12. So you put 12 here. You come here and use this 2 to multiply. 2 times 4 will give us 8. You record it here. 2 times 2 will give us 4. You record it here. Then add up this. You bring down your 0 here. 2 plus 8 will give us 10. Write 0, carry 1 to this. Put the 1 here. 1 plus 1 is 2. 2 plus 4 is 6. So this is going to give us 600. But remember the question said, what is the smallest number that is divisible by 100, 120, and 150? The question did not just tell you to find LCM of these numbers. I want to write this. So your answer, the way you present your answer should also go in line, should agree with the question they asked you. The question is, what is the smallest number? So I'll conclude, therefore, the smallest number that is divisible by 100, 120, and 150 is 600. Which means that 600 is the first smallest number that is common that you would see in 100 times table, 120 times table, and 150 times table that can be divided by 100, 120, 150, and there will be no remainder. Get set for our last question under LCM here. Just think about this. I gave you 3 containers, okay, of different sizes, different volumes. And then I ask you to use these containers, fetch water, and fill another container. Now, I gave you this condition. The condition is that this container you are going to fill with water using these 3 containers, just like cups. Maybe if I give you 3 different sizes of cups, and I said you should use these cups to fetch water and fill, let us say, a bucket, a small bucket. And then the condition is that as you are fetching water using these 3 cups and you are filling this small bucket, you continue pouring until when this bucket gets filled, there will be no water remaining in any of this cup you are using to fill the bucket. I now ask you, what will be the size, the smallest size of such buckets? How do you get the size of that bucket? This is a kind of mind-blowing question, is that not so? Alright, you're welcome to solving this question we have on the board. There is a problem here, let's see. What will be the smallest volume of a container that can be filled with water at an exact number of times using 15 cm cube, 35 cm cube, and 47 cm cube containers? So how do we solve this question? Now we have these containers, it's just like the 3 cups. Now there is another container, the smallest value of the container that you are to fill using these cups. You will fetch water using these cups or these containers and then fill this one here, fill the container, but we don't know the size, the volume of this container here. But all we know is that any one of these containers, any one of these containers you have here, 15 cm cube, 35 cm cube, and 47 cm cube, it can fill this container exact number of times. Exact number of times means there will be no remainder. Like I explained earlier, when you keep filling, the time that this bucket will get filled, the cup you are using, there will be no water in the cup remaining, and it will be complete. Well, it's interesting to know that this question is still an LCM question. Because if I give you a cup to use in filling a container, and I can fill the container with water completely, there will be no remainder, no water will be remaining by the time this container is filled. It simply means that the cup can divide the water that that container can fill without any remainder. This is still another knowledge of LCM. So let us see how we solve it. All we are going to do is to find the LCM of these 3 containers. The answer will give us the volume, the size of this container that is to be filled with water at an exact number of times. Solution. I'm going to bring out 15, 35, and 47. So 3 columns. 15, 35, and 47. Okay, let's see how fast we can be in doing the division. 2 cannot divide anything here. I believe you know the reason already. You can revisit and watch our previous video and question number 3, okay? But 3 can go. Since 2 cannot go, you can't use 2 to divide anything. You check for 3, and 3 can go there. 3 can divide 15, it will give us 5. 3 cannot divide 35, so you bring down 35. 3 cannot divide 47, so you bring down 47. Here, 3 can no longer divide anything here. 4 can no longer divide anything here. 4 cannot divide anything, so we check for 5. Yes, 5 can divide. 5 can divide 5, we'll get 1. So this column has finished, it has gotten to 1. This is 35. The last digit here is 5, so 5 can also divide it. Rule of divisibility. If 5 divides 35, it will give you 7. Check 5 times table. You'll see that 5 times 7 will give you 35. Alright, 5 cannot divide 47, so I'll bring down 47. Here, 5 can no longer divide. Can 6 divide any number here? No. So we'll check for another higher number, 7. 7 can divide. This has already gotten to 1, so we'll bring down 1 here. 7 can divide this 7, it will give us 1, so this column has also finished. We'll come here, 47. 7 cannot divide 47. 7 cannot divide 47, so we'll bring down 47 here. Alright, at this point, no other number can divide apart from 47. 47 is a prime number. There is a number we call prime number. This type of number, only 1 and the number itself can divide itself. Alright, for example, 7, only 1 and 7 can divide 7. 13, 11, only 1 and 11 can divide 11. Only 1 and 13 can divide 13. 17, only 1 and 17 can divide 17. So we'll call such numbers prime numbers. So here, 47 is the only number that can now divide. So I'm going to bring down 1, 1. 47 can divide 47, it will give us 1. So we can now find the LCM. The LCM of 15, 35, and 47 is equal to 3 times 5 times 7 times 47. Let us do this multiplication and see what we would get. 3 times 5, okay, 15. 5 times 7 will give us 35. 35 times 3, 35 times 3, they're about 105. So let me multiply this and see what we're going to get. 105 times 47. Alright, 7 times 5 will give us 35. 5 carry 3. 5 and then carry 3. 7 times 0 is 0. Plus the 3 would give us 3. Then 7 times 1, which is 7. Use this 4 to now multiply. 4 times 5 is 20. Write 0, carry 2. 4 times 0 is 0 plus the 2 you carry will give us 2. 4 times 1 is 4. Then add up this multiplication, then this part you add. Bring down your 5 here. This is 3. 7 plus 2 is 9. Then bring down your 4. So this is 4,935. So what does that mean? It means that the smallest container that these containers can fill with water at the exact number of times, so that there will be no remainder, that container is 4,935 centimeter cube. I'll conclude. Therefore, the smallest volume of a container that can be filled with water. See, I'm taking my conclusion from this question here. We are asked, what will be the smallest volume of a container that can be filled with water at an exact number of times using this container of these values? So that can be filled with water at an exact number of times using 15 cm cube, 35 cm cube, and 47 cm cube container is 4,935 centimeter cube. That is our answer. In our next class, I'll be teaching you highest common factor. Until then, make sure you study this LCM, because we're still going to use the knowledge of LCM to understand HCF and even solve questions on HCF. Remember to study your book and submit your assignment. That will be given to you when it is the time to submit it.